The system we're talking about will authenticate device connections. It will create one Phoenix channel socket per device. It will orchestrate firmware updates, aka deployments. It will provide support tools for specific devices, like the console, the scripts, the reboot command. It will track connectivity, health metrics, and logs, and it will generate firmware deltas for patch upgrades. If this makes no sense, that's called a cold open. So this is my presentation. It's called Tying It All Together, and fundamentally, I'm not giving it to impress you with anything new and flashy. I'm trying to just show an example of production Phoenix app, because I hear people asking for that. And we have one, NervesHub. It's a fully open source service that has existed for a long while now. And it provides over-the-air updates for Nerves devices, or any embedded devices, but it focuses on Nerves. You can see there's a small Nerves logo or Nerves Cloud logo in the corner. That is a managed hosted version of NervesHub run by me and Josh Kilderimus. So if you're playing around with Nerves and you want to be able to update your firmware devices, there's a generous free plan. We don't really care to charge for hobby use. If you run a business on top of Nerves, do reach out because we want to talk to you specifically. But that's the shilling for this one. There's a bunch of history. It has an intricate, mildly fascinating history. We won't cover it at all. There's no time for that. So we're focusing on present and future. At the sort of big level, NervesHub consists of the Beam, Postgres, and object storage. And soon it will involve ClickHouse. The current group of maintainers are me and Josh Kilderimus from Nerves Cloud. Then there's Nate Shoemaker and John Carstens. I keep wanting to call him Schumacher because European. But yeah, and John Carstens from SmartRent. And we get a lot of scale and production insights from SmartRent. They run a lot of Nerves devices. I think the polite way to say it, because they're a public company and they're careful about numbers, 6 digits is sort of the area. And then there's my colleague over there, Elin, also from time to time gets to contribute to NervesHub. I do a bunch of things, so this is an aside. Most of my presence in the Beam ecosystem can be found through Underjord in the middle there, and the link has links out to almost everything I do. Right now, I just want to mention Goatmeyer Elixir. It is Sweden's first, to my knowledge, Elixir conference. It's in Varberg, September 10th to 12th. Don't miss it. And it comes with Europe's first NervesConf. So that's a bonus. And you can actually rent your stay in a prison cell if that helps sell it. It's in a fort, so that can be nice. The lineup is actually ridiculously promising, but I won't dwell on it. So, what do we use to build our production Phoenix application? We use Elixir, we use Phoenix, we use Ecto. That's the usual stuff. We use a lot of Phoenix channels. Some apps do, some apps don't. We do the web UI in Phoenix LiveView. That's pretty expected, but not everything. It doesn't fit for everything, but it fits for this. The CLI, we have a CLI for uploading firmware and automating and all that stuff. That's built with Elixir, wrapped in a burrito. Who here knows the burrito library? Decent bunch. So it essentially gives you a single binary for an Elixir project. And we have a homebrew installer, which is a nice bit of DX. We specify our API in open API specs, and then we use Oban for a bunch of various tasks like firmware processing, tidying up maintenance tasks. And then there's a client library that runs on device, built in Elixir with Slipstream, which is a Phoenix channels client, which is important when you're connecting to a bunch of Phoenix channels. Is that the same slide? Okay. So we do a bunch of the usual stuff, and it's done the usual way. So for anything, create, read, update, delete, listing things, we do what you'd expect from most Phoenix applications. We use Phoenix context modules, that is, modules with functions in them. roughly organized by domain, business domain, and usage. We have good test coverage overall. I would like to try Ash to try and cut down on the boilerplate of all this and get it very systematized, but it's a fairly reasonable code base. If you look into it, I don't think you'd be surprised if you've seen a Phoenix app before. Now, we build the UI in LiveView, as I mentioned, and it saves a lot of work and makes it very easy to keep things live and real time. So we're not talking hard real time, of course, we're talking about making sure the online indicator actually updates in good time and showing a progress bar when we're updating a device, that kind of thing. We're not doing anything particularly fancy. We're running very straightforward LiveViews. We use PhoenixTest for testing a lot of the UI functionality. And if you've ever had to set up, like, is it Wallaby? That's the browser testing. It's good, but it's also a pain because it's browser testing. And PhoenixTest is much, much easier. It doesn't give you quite the same assurance, but it gives you some very good ones. We're currently in the middle of a design and UI overhaul, so we have a sort of big V2 UI change. This duplicates a lot of the UI, but we're mostly duplicating the templates, and we're trying to keep the logic a single implementation for most pieces of UI. And that has worked pretty well. The old UI made very poor use of space, and the new UI makes great use of space, gives you sort of full width tables and all that, a lot of important stuff if you're working with a lot of devices. But there's still a few corners left to rework, then we'll be able to drop the old UI entirely. We use JavaScript here and there when we see a good reason to. So we've done some experiments. If you saw my talk in Berlin, I showed a world map that used leaflet.js, and typically when we show a small map of where your device is, we're using Mapbox. We have some charts. Last I checked, we were using chart.js. It's not really my area. And then we have a console which uses some kind of JS terminal thing that I can never remember what it is, probably xterm.js. You can see a smidge of the default Nerves prompt sort of on the side there, and that's in the web. So the domain, the different parts, domain thing is the technical term. We have accounts and orgs, pretty standard. We have products, which is largely products or projects, you could call them. Then we have the specific devices, and then we have device lifecycle information, which is important. And then we have device metrics and connectivity, which sort of gets its own area under devices. And then we have firmware, and then separately deployments or deployment groups, because we're in a bit of a naming transition. I think deployments and deployments groups, none of them will make it. I think we'll have another name eventually. So what does it do? This is what I started with. We authenticate device connections. We provide one Phoenix channel socket per device. We orchestrate firmware updates, aka deployments currently. And we have support tools for various, for handling a specific device. So maybe you want to open the console or run a script or reboot the device. We track connectivity, health metrics, logs, and so on. We generate firmware deltas for being able to do patch upgrades. And I'm going to go through sort of how we approach these. Authenticating device connections, that might sound simple, treacherous in that way. So username and password, do you want to put a username and password on your device? Probably not. Do you want to put an API key on the device? That's called a shared secret, and not ideal for most sort of big production environments. So we use MTLS, aka mutual TLS. So you can put a hardware security module on your board. That one can hide a private key as hard as hardware can hide it. We often use the Nerves key, which is a tech microchip, a tech chip. And Erlang provides this very nice Erlang SSL engine support, which hooks into the OpenSSL engine support and lets us sort of handle all of that from Elixir, but plug in at a very low level into the SSL process. So then we have two approaches. We have device certificates and JIT-P, or just-in-time provisioning. The device certificate approach, we upload essentially an allow list of like, these are the public keys or device certificates for the devices we expect to connect, and we will only allow those devices. Or we have the JIT-P approach where we set up a CA, a certificate authority, for this is the key that we expect to have signed any device that we want to allow in. And if one of those devices shows up and it clears all the crypto checks, we create the device information on the server at that point. We also take good advantage of the ease of integrating with Erlang's SSL for the server side of things, where when you're getting a lot of device connections and you want to apply a rate limit, because we're doing custom SSL stuff, we can't really sort of terminate SSL out by some cloud proxy thing. We need to get involved in it. And that's perfectly feasible to do with the Beam. It's no problem. And ideally, you want to reject connections. Like if you're like, no, we're good, we're rate limiting. This node does not want more connections. You want to start rejecting people before you do the TLS handshake and all the computation it involves. And then also, we want to skip verifying the CA trust for known device certificates. If you're cleared on the allow list, then we can do a crypto handshake on that. We don't really need to check if you're on the CA because it's not relevant anymore. So a few custom things there. Then we have shared secrets. This is mostly for onboarding and hobbyists and trying out the platform. It is much simpler. It is not as secure. It is more fragile in terms of crack one device, you have the key, now you can connect more devices. But if all this authentication stuff passes, we essentially create a WebSocket connection with a Phoenix channel on top of it, and now we're in Phoenix land. This has only been tested into the hundreds of thousands of devices for NervesHub specifically, so we don't know the bounds, but there is this ancient blog post about running 2 million Phoenix channels on Phoenix, and this was way back. This was before the JIT. So I think we could beat it if we bothered to. We set up a device channel for firmware updates and to track online and offline. We set up a console channel for the remote console. That should really be an extension thing, but that's a later problem. It's older. And then we added the extensions channel for health reporting, geolocation logging, and more that are not critical, because the extensions need to be separated. We always want to be able to perform firmware updates. Ideally, we get health reports, but we always want to be able to deliver firmware updates. So the extensions are sort of the stepchild. We don't treat them as nicely. Bad family advice. Because WebSockets are nice and they allow bidirectional communication, most communication is actually server initiated, and that's important. Because we can't trust the client, like even with the crypto, we can't trust the client to behave well. Because internet weather might be bad, telecom providers occasionally go down, I suppose they don't use Erlang. And a fleet of devices, when you're coming up into the hundreds of thousands, they find all sorts of weird reasons to synchronize and sort of essentially attack your servers for the slightest thing. And at that point, it becomes important that they don't have the instruction to send a health report every minute. It's better that your server tells them, I want a health report now, because you can always switch that off much more easily than you can switch it off on 100,000 devices. When devices constantly reboot for some hardware problem, they might be connecting over and over and over again at a fairly tight clip. So letting the server control much of the communication is very helpful in building something robust and keeping control of your fleet. Then we have orchestrating firmware updates, aka deployments, because we gotta deliver firmware. So we use Process Hub, which I believe hooks into Postgres, but it fundamentally just ensures one orchestrator is running in our cluster per active deployment. So we don't have to coordinate a bunch of details between a bunch of different orchestrators running at the same time, trying to do the same job. Because it's not that hard a job, really. It doesn't need to be distributed in that way. So we essentially make a singleton for doing this. And if it accidentally splits and starts to run updates in parallel, it is not the end of the world. So it's not really a hard distributed systems problem. We plan to use more sort of a workflow style where there are stages to deployments and stuff. That's not there yet, but we have a lot of stuff we want to do with the orchestrator now that it's sort of under control. The support tools. When investigating or supporting a device, there's a number of common operations you do. You want it to reboot or you want it to reconnect. But then there's also the custom operations. Your device has particular peripherals, particular sensors, and you want access to those. You can write Elixir scripts, so-called support scripts, and you can just run them with a single click from the UI. Very nice. This happens using the console channel. And the console itself gives you an IEX prompt on the device, unless you've customized it heavily, which is super flexible for figuring out why is this thermostat misbehaving, or what data are we actually seeing that's causing this. When you have 100,000 devices, you see random bit flips. This nil turned into a 5 for some reason. And actually, the beam is fantastic for that because, oh, unexpected value, something crashed. Oh, and then it restarted, and it was nothing. No problem at all. But values changed mid-runtime. Hot code updates via pasting code sounds like a very, very bad idea. And for some installs, it might be. For figuring out problems with consumer devices when someone's angry, it's pretty powerful. So yeah, we use a lot of hot code updates in Nerves. Not the way people expect, but we paste a lot of code sometimes. We also support an experiment with using LiveBook, pretty much the way Vittorio and Polo did with connecting a LiveBook to a device. I have a support script that I can just click, and it sets it up with my own Tailscale install, and then I can just connect to it wherever it is. We also track connectivity, health metrics, and logs. So default metrics like CPU usage, RAM, disk, networking, and custom ones that you might need for your sensors. Maybe you want a history of your sensor readings so that you can check if it's reasonable. We'll give you some geopositions so you can get a map. You can provide other metadata. We use Erlang alarms via Alarmist, which is very helpful to find out like sometimes passing, sometimes permanent problems with your device. We also track the connection history, which is especially important for like LTE deployments, where it's like, oh, this device keeps hopping online and offline. That's a problem. Let's figure it out. We just started streaming logs. This is in Nerves Cloud, but I don't think it's on by default if you just set up NervesHub. I think it's opt-in still. This all sort of feeds together into a health concept, where we try to get an idea of, is this device healthy, or does it need attention? And there's a bunch of things we want to do with that. Maybe we halt deployments if health starts to suffer, that type of thing. But we're building up this concept, more and more information to help serve the device fleet overall. This means time series data, metrics, connectivity, even the logs. And because we don't want to swamp Postgres, which is our transactional store and sort of the critical bit, we are looking at ClickHouse, and I believe we're running it now for the Nerves Cloud parts, especially for the logs, but also health, the metrics and all that will move over. Because ClickHouse is essentially the Postgres of I'm losing the word, but yeah, column stores, analytical data, that kind of thing. We also generate firmware deltas for patch upgrades. I'm going to breeze through this because I'm running up on time, but fundamentally, WAP that we use to update devices can calculate the difference between an older version and a new update and only send the diff, which is very nice, especially if you can save megabytes times 100,000 per version upgrade, and you're footing the LTE bill. There's a lot of work happening there right now. Oban handles the generation task. This is a sort of out-of-band, mildly heavy operation. So when a new deployment is created, we check which versions are in use, and we generate from those versions to the new one that you want to deploy. But there's nothing surprising in this app. If you look at it, you should check the source, look into it. You can probably understand it. It is a highly concurrent service workload. It's live real-time web UI. It scales well both horizontally and vertically. It's been tried and tested. It addresses special cryptography needs that I think would have been a pain to do in a lot of languages and a lot of platforms. It does background processing, asymmetric workloads. I've worked in Python. I've worked in a bunch of things. I think this would have been a lot of different services. It's just one app. So you should check it out for yourself. PR's welcome, of course, if you have anything you need, but also just check it out if you want to talk about how it works, if you want to understand how, or you have suggestions to improve it. Do come along and check it out. That is the whirlwind tour of NervesHub. Thank you for listening.
Thanks a lot. The lunch is approaching clearly, but maybe we do have some questions in the room before that.
Yeah, you can always find me after as well.
I have a small question.
Yep.
Maybe you could explain who are your clients or what is the use case, just to give me a taste of what could be connected to Nerves Cloud.
So I work with SmartRent over in the US. They make smart thermostats for entire rental building installs. So if you build a new rental apartment complex and you want to put some smarts in, you want to put in leak sensors, you want an IoT hub so you can be told about leaks before they get very costly, you want to manage the temperature, you want to make sure that tenants don't overheat or underheat the apartment, that kind of thing, building automation, but also with people involved. That's one where there's at least 100,000 devices connected. But then we also work with, for Nerves Cloud, we work with a company called Evercam that does construction cameras. So they're up on massive cranes and top construction sites, grabbing frames every second to provide time lapses and compliance follow-up for the construction industry. The platform doesn't really care what your device is doing in that regard. You can customize it to make use of like if there's sensors and stuff that would be good information to have. But essentially, Nerves works with anything that's kind of Linux level. Like microcontrollers, then we're starting to look at Atom VM, and we're having conversations about integrating Atom VM devices with NervesHub. Fundamentally, NervesHub is not specific to Nerves, and I think we'll see more of that in the future. I definitely have some plans.
Thanks a lot. So now I think we could make the final thank you to Lars.
Thank you.